Okay, today I'm going to show you how to graph a compound inequality. So as we talked about before, a compound inequality is just more than one inequality separated by an and or an or word. So remember, this has either the word and or the word or. So basically, you have to graph two inequalities, and then you got to decide on the and or the or what you're going to keep. So let's say we want to graph this one. We have x is greater than 3 or x is less than -1. So firstly, we get a number line, and then we're going to go graph both of them separately. So first, we're going to graph this one here in red, and we're going to do it above the number line just so that we can put our answer on the number line itself. So the important points are going to be -1. Let's put a 0 here. There's -1 and 3. And the important points we know is because that's what these numbers are. So let's deal with x is greater than 3. So we'll do the red one first. If x is greater than 3, we're going to go to 3. It's going to be an open circle because there's no line underneath it. And greater numbers are to the right, so we would shade to the right. So this would be the graph of x is greater than 3. Now we're going to go back and I'll just pick blue this time. We're going to do this one in blue. So we got to go find -1. Again, it's going to be an open circle. And then, because there's no equal sign, and then x is less than -1, these are numbers to the left. Okay? So now let's go back to the original and or up here. If it's an and, we want to shade where both exist. If it's an or, we shade where any exist. Okay, so let's do the and first. My solution, and I'm going to make my solution in, let's pick green. Okay, we're going to make my solution, is where for and, actually I have or right here, so let's do or first, is where any solution exists. So at -1, are there any solutions? Well, an open circle says it doesn't exist here, so at -1 there's no solutions, but there's an open circle, so I'm going to put the open circle here. And I'm going to do the same thing at 3. It's an open circle, so I'm going to put the open circle here. To the left of -1, the question is, does any solution exist? And the answer is yes. This blue one exists, so we're going to keep it as part of our solution. Between -1 and 3, do any solutions exist? No. There's no blue, there's no red, so there are no solutions here. To the right of 3, do any solutions exist? Yes. This red one exists, so we're going to keep it. So our solution is going to be this green thing where either the red or the blue exists. So our final answer is right here. And this is the only part you need to see. These up here just help you. This is your solution down here. Now if instead we have the word and we're going to do and right below it. So this was for or. And let's do it in yellow. This is going to be and. So and I want where both exist. Well, to the left of -1, only blue exists, not both exist. So we're not going to include to the left of -1. At 0, nothing exists, so we're not going to include it. Between -1 and 3, nothing exists, so we're not going to include it. At 3, only nothing exists, so we're not going to include it. And to the right of 3, only red exists, so not both, so we're not going to include it. So this is actually a completely empty line because there is no solution. So we're going to just leave the line empty because there is no solution. So in this particular case, for or, we had this green solution, and for and, we had a completely empty line because there is not both. Okay, so let's do another one over here. I'm going to delete this a little bit, so just to give us a little bit more room. Let's do oops, how about not yellow? There we go. How about x is greater than 1, and we'll also use x is less than 4. Okay? Again, we're going to do both and or. So let's go ahead and do or first, just like we did before. So we're going to graph our original two. I'll do the first one in red again. So let's get a number line going over here. We need a 1 on it, and we need a 4 on it. So 0 ends up being over there. At 1, we're going to have an open circle. As a matter of fact, let's just make it a little bit more interesting. Let's put in or equals on that one. Okay? So at 1, we're going to have an open circle. And it says, I want bigger numbers, so we're going to shade to the right. So everything to the right gets shaded. Okay? On the left side, let's do this one in blue. So we got to go find 4, which is right here. It's going to be a closed circle because I see the or equal to. And we are going to shade to the left because I want numbers smaller than 4. Okay, so those are our 2. And again, just like before, our solution here, we're going to do on the number line in green. For or, I want if one or the other. So let's look at our key points. 1, and the question is, does either blue or red exist? Well, red does not exist, but blue does, so we are going to keep 1. At 4, both blue and red exist, so we will keep 4. To the left of 1, the blue exists, so we're going to keep that section. In between, both blue and red is, so that's at least one of them. We're going to keep it. And to the right, the red exists, so that's at least 1, so we're going to keep it. So this ends up being the entire number line. This would be all real numbers. So this is the case for for or. Now let's look down here at and. So again, I need another number line. Now if this was and, I want to know where both exist. And is always both. So again, we're going to do the key points first. At 0, or at 1, red does not exist, blue does exist. That is not both. That is only blue, so we're going to put an open circle down here. At 4, we have blue that exists, and we have red exists. They both exist, so we're going to have a closed-in circle because both exist. And then let's look at each section. To the left of 1, only blue exists. It is not both, so we will not include it. Between 1 and 4, we have both blue and red, so we are going to include between blue and red. To the right of 4, we only have the red one, so we are not going to include it. So we're only going to graph between 1 and 4, open circle at 1 because only blue existed, and a closed circle at 4 because both blue and red existed. So this is the graph for and. Okay, so if you have questions, make sure you ask, but generally speaking, and is both lines, and or is any lines. Now, one of the interesting things that happens is most cases, and by all means, it's not all cases, but most cases, what you're going to find out is that an and is going to look like our last case, where you're going to have 2 numbers, and you're going to end up shading in the middle. An or, in most cases, you'll have a pair of numbers, and you're going to end up shading in the outside section. Okay, this is what happens the majority of the time. Not always, so make sure you look in your particular case, but the majority of the time you're going to find out that and ends up being in the middle and or ends up being in the outside. Okay, but if I give you individual cases, check them the way I did these here because they're not all. If you have any questions about graphing compound inequalities, please make sure you ask.